Hello guys, welcome to another Rust video in our Rust series. And in today's video, we want to look at the user-defined data types or the red Rust. Value. And here we are. What are user-defined data types? This display. These are data types or types that are defined by you, the developer. I want to print or the software engineer that is writing the software. And depending on the needs that you have, this will determine how you craft your data types. This will be we know that they are green, inherent or native data types within the programming language. Things like string, and integers, signed and unsigned, to floats, and all that strings. And this, but sometimes you might need something specific that is combining either some or one of those, or blue, to craft something that is you watched quite different. Popular series among. That's what we call user-defined data types, and they come in three forms. And these include structures, which we are going to call structs, enumerations, or in order to do that, we'll call Rust. Come from languages like C++. You of course you know about structures, and we are getting an error the same as couldn't read main stream classes in C++. And that's a story for another day. And on this channel, we also have advanced C++ videos. Please check them out. So user-defined data types allow you to express your data in a really pretty unique way, and we are going to see that they fall in naming convention of camel case. And why don't we start dive in with the basic struct that you can find. So to declare a struct, we use the struct keyword given us by the language, and we can declare a struct and we can call it dummy. Now this is a struct, and and at this level, this struct is what we call a unit struct. And for you to sort of see what is happening there, you declare a function main, and we can let a value or let value equal to dummy. We something like that. We print. So this is what we call a unit struct, and is declared. There's no data associated. We call the compiler it Rust C. It's just there. Do I have it? You could be wondering, why would I need something like that? Oh, there could be a reason. One of the created cases that you might find yourself in why you would need something like binary. Assuming you're writing a program where you need a specific error and push out to the user. So we have, you can write your error, the green, like a struct like this, the green, and the assumption is that that error doesn't need much explanation. So it can be a unique. So that's how you can find yourself in. But as you know, look at the programming languages must give us all the resources and utilities to express ourselves. The tuple struct to express what we want. So, and that could be lastly the one we can think of is, who knows, the program that the C++ software engineers write around the world, or the struct. So that's one of the naive declare that. Of course, we declare that by using the struct keyword that you can find yourself in a position where you need this. We can call it anything. Now followed by the struct name. This time we are going to call it prayer. So we are presenting information about some printing this time. But the next thing is calibration. The kind of printing that struct keyword done here. I think I'm going to get an name and calibrate. But I'll let that happen. We are going to declare some fields. Like name, we can learn something from it. The field type string. So I call my terminal, and this will be one of you will be using this a lot in the Rust compiler when you're writing Rust program. RS and yes, Rust program predicted. This is pretty common. So prayer IQ. Rust, how does the prayer thing? Dummy doesn't implement std display. So the number of frames, the Rust dummy doesn't implement an integer U8 display formatting string, and the score and the string the dummy getting formatted with the default formatter. Maybe an online game. We're getting help here. The reason why I'm doing this is that you can see that when you get frames, read your score, and you can find solutions in there. So we want to write standard formatted display function is not implemented for the dummy. And I want to remind you that in this function or in this program, you may be able to use this. We are going to talk about some of the things we've looked at. What's this? The print, like pattern matching and match. So if you haven't watched that, instead you can go back in our video playlist. We have things like, if we are to print this, we are going to use this. We have talked about pattern matching. So we are declare a function bump player score, and we are declare the player. Sorry, we are passing an argument, a mutable argument. If we are to use this, we need player argument in macro of the struct type player. And that means we want to have our live, I think, struct mutable. You can see that the values here in the struct are not mutable. Actually, if we want them to change, that means we are going to manipulate one of these. The other one is the fields, the display. Either increase them or decrease them. Let's see. So we have the score round. Actually, this means we are going to change the score, which is a U16. Ooh, it works. And the int 16. We call main. The one that is created, the binary file. And we have dummy. We are saying that out. So we saw that how to access values of the base fields of the struct. We use the dot notation. So if we want to access the score field, unit struct, what do we want to do to the score? We want to increase it by how much cases, maybe by that you want a default value that you want. So the rest of the work is passing out an error. We are not going to manipulate a lot of the user depending on what you're writing, and this we want to update cases. So this is how we write statistics or player struct, so to say. So think about this as a game. If you that's how we have thought about game programming. So unit struct is something I'm thinking about sizes at runtime because they have no data associated with them. Programming. I've said that. Pretty interesting. And so we have name. We've talked about the possible use cases. They are coming in our C++ videos. Sit down and think. So depending on the problem you have. Name, and that's how we access values. They can be used to model state fields, not data state associated with them. And the one I can think of IQ, is when you want the player IQ an error to the user or error types. And we are saying where you don't need much description of that error. IQ. So, or you can use them in another implementation where you have a state machine. Then lastly, where you have on sleeps, things like that. If you know about state machines. So that's those are some of the ways we can think of when it comes to this player, the unit struct. Then we have what we call a tuple, easy peasy, a tuple struct. So we want to use this struct. How do we declare it? We declare it by beginning with the struct to the main function, and then we declare the name of the struct. This time we can call it color. We want to declare something, and we know the RGB colors be used in order to. We can declare the types here. The unsigned int 8 function. This always exists in as a tuple. Declare a variable name. And that name might declare another U8. This player is too much. Maybe U8, another U8. But when you do this, you convert struct. And in this struct, we can see at least we have some resemblance, or so we declare a resemblance of the variable associated with player struct, which is player. For us to use this, we can. And we have calibrations. So we have the name, which we've just declared. We can let the IQ we want to pass maybe 178 is white, a primary color. We can declare a variable, let white variable. Friends, hold guy has a lot of values in color, and now we can pass the values of these colors and the score. That colors how much have this range from 0 to 255, depending that one. 255, where 00. Remember always to terminate this with and the 255, 255, the semicolons. So those are the unsigned int 8. We can call our from the struct that we have bump player, and we can access different values of which takes the variable player that we've just this color component created, and the score, and we can say, or we can access the first component which we want to call red, so which equals to run this program. Dot. This is the syntax of accessing values in a struct, especially in this increase struct. So we terminal view. We call the white which is the variable declared to the struct called the main, and then we want to get the index, and the index there is 0. But that's okay. And then we can let another value or variable, never equal to green variables, and which is equivalent to white dot one everything. So that is the second main index of the color. And voila, this is where we are. We have forget about colors that this RGB. We have the player starts out to white. The name is Anderson. The IQs 1. So those are the indices, and that's how we 32. We access values in the struct 120 specifically in this struct. That's all I have for you guys in this video, and I hope it is nice and you found it interesting. And this has been about user-defined data types, specifically about structs. It has been a long video, but yeah. Bye-bye. Don't forget to leave a like, comment, subscribe, and bye-bye.